Inscribed angles are different from central angles in that they're actually formed by two chords. So not two radii, but two chords. For instance, chord AB and AC form the inscribed angle, angle, there we are, angle BAC. And if you look carefully, you can see that angle BAC, this angle here, subtends, creates, or includes this arc BC. So now in the next slide I'm going to talk about how this angle measure, here angle BAC, is related to the arc. Remember, for a central angle they're equal, not quite the same for an inscribed. So to illustrate this, what I've done is I've drawn a diameter. So you know that AB is a diameter, AB is diameter, and we know that that is in circle P because P is a point there. So PC is a radius. It's a radius that is perpendicular to AB. Okay, so here's what's going to happen. I'm going to construct an inscribed angle by constructing, by constructing two chords, one connecting AC and the other connecting C and B. So what this gives us is the inscribed angle, angle ACB was the inscribed angle, and then that inscribed angle subtends, there we go, get the right tool here, and that subtends arc ADB. So that's subtending this major arc here. Now looking at this and knowing that AB is a diameter, that means that arc ADB, big difference, right? Start and end, and then that point in between. So ADB, and of course that's a major arc. Why? Because it's equal to 180 degrees, because it ends up being half the circle. Now, this is where we need to focus then on what's going on here. PC is a radius that's perpendicular. Now, if you look carefully, that would mean that AP, which is a radius, PC, and PB would all be congruent. And if you look a little bit more closely, hopefully, you see not one, but two isosceles right triangles. Now, if these are isosceles right triangles, we also know they go by another name. They're called 45, 45, 90 right triangles, which means that's 45, and that's 45. The reason this is important is because then we can take a look at the inscribed angle, angle ACB, and it equals 90 degrees, 45 plus 45. Which means if the inscribed angle is 90 degrees, it subtends an arc that is twice that. So putting that into an equation, 2 times angle ACB equals arc ADB, because 2 times 90 is 180. This leads to the general case that if you have an inscribed angle, it subtends an arc. And it subtends an arc measure that's equal to twice the inscribed angle. So for instance, if the inscribed angle was 30 degrees, it would subtend an arc of 60 degrees. Now the central angle that subtends the same arc, right, would end up being equal. So this arc and this angle would end up being equal. But that's the key thing to take away. 2 times whatever the inscribed angle is equal to the measure of the arc that it subtends.